am Suchetana Manna and working on green and bulk synthesis of hydrogen at Bose National Center for Basic Sciences. Today, we'll demonstrate the production of hydrogen on a large scale using our material, which is eco-friendly and low cost. Although hydrogen has great possibility as a clean energy source, presently production of hydrogen is very energetically extensive and it creates large pollution. In addition, the materials which are presently in use are very expensive and precious metal such as platinum. So these problems has made it very difficult to produce hydrogen on a large scale. For that, we have synthesized a transition metal chalcogenide that will help us producing hydrogen in a large scale using renewable energy sources like solar energy and wind energy. In comparison with the state-of-the-art material, our chalcogenide material is very easy to synthesize and it can be scaled up in a large amount for industry purposes. Here, we'll be showing you the laboratory scale synthesis of our material. For that, we need metal and chalcogen raw materials in powder form. This powder is then transferred to a custom holder for hydraulic press to make a pellet out of that. So after taking out from the hydraulic press, the pellet looks like this. The pellet is necessary because we need to maintain the ratio of the raw material intact, and the pellet will help avoiding material loss. We'll keep this pellet in a quartz tube like this, and we'll keep this sealed quartz tube in a furnace for 48 hours at 900 degrees Celsius temperature. So now, after taking it out from the furnace and rapidly cooling it using water, the material looks like this, a black powder. In this process, we can synthesize this material in any scale as per the requirements. There will be no purification process required for this synthesis. That's why it's very industry-friendly process. So here we have taken some amount of powder in this up and off, and here is our binding solution. We'll mix this together. After mixing, we need to sonicate this for 1 hour to get a homogeneous mixture like this. Now this catalyst slurry is then painted on a carbon cloth that is cut into required shape and size to fabricate our working electrode. We can even change the size of the carbon cloth and the amount of slurry used to scale up the hydrogen production. Now this electrode is left overnight to dry.
So today is our next day and our electrodes are dried. Now we can mount our working electrode into our working electrode holder and use it for the 3 electrode setup. Now we are using this 3 electrode setup for laboratory purposes only because we need accurate and precise measurements. But we can also use a 2 electrode setup for industry purpose where our material will be used as a cathode material. So now we will start applying the potential using a potentiostat. So let's see what happens. This system has been tested for more than weeks continuously. The most unique feature of our material is, unlike other catalysts which tend to degrade with time, our material increases its efficiency with time. By using cheap and readily available materials, we have synthesized electroactive chalcogenide material which is useful for sustainable and long-term hydrogen production. Now we are focusing to fabricate a device which can harvest the solar energy to run the electrocatalytic hydrogen production in a bulk scale.
So in conclusion, hydrogen is the green future. For vehicle application, it cuts down the carbon emission and also the air pollution. For chemical synthesis, it's a very energy efficient thing. So in conclusion, hydrogen for everyone.